Okay, let us start this simulation as based on Bohr's atomic model using the Planck's quantum theory. As this is the have a different cell as structure is a modification. As here center have a nucleus and revolving electrons are revolving around the nucleus. Suppose when we falling off hydrogen light on this particular structure here, the electrons it will moving around the nucleus in a definite path that we called as cell or orbit, having a different cell as this one is called as K cell, this is L cell, this is M cell, this is N cell, this is P cell. A various cell it will represented as 1, 2, 3, 4, 5 respectively. Electrons are revolving in its own path that we call as orbit or cell. Whenever electrons are moving around the nucleus, it does not lose or gain the energy. It means energy remains constant. As another thing, whenever those cells are nearer, as closer to the nucleus, they are having the more energy, and because of lot of attractions is occurs in between the nucleus and electrons. Then another thing is those cells are away from the nucleus far distance, so they are having the less energy because of less attraction in between the center of nucleus and outermost cell. As come to the third point, as here whenever the electrons are jumps from outer cell to the inner cell, so then the emission of radiation is occurs that we called as E1 is inner cell, E2 is outer cell. From outer cell to inner cell, that is E2 minus E1, it shows h nu, nothing but photons. And another thing exactly vice versa, whenever the electrons are jumps from inner cell to outer cell, that we called as absorption of photons, then that means E1 minus E2 is equal to h nu. H nu is nothing but photons, h means Planck's constant and nu is frequency of radiations. See here, the whatever the wavelength it required, whenever white light is falling on this structure of atom, so here this region is nothing but UV region, and its wavelength is starts from 380 nanometer to 780 nanometer. On this region, the different color is formation takes place. As this is the red colored as light is falling on this particular structure, so then it will shows the different region. See here, have different transition based on using the different wavelength that is measured in nanometers, and their transition have a different range. As from first cell to 6 cell, from first to 5, it requires 95 nanometers. As like different cell transition, it requires the different wavelength. Simple conclusion, whenever increasing the wavelength, so then here the cell number is also away from the nucleus. It means 2 to 4, 486 nanometer, again away from 3 to 4, again above the 1000 nanometer. As here, this is the electron energy level. As energy level, this is the ground level. Electrons are jumps from ground level to the higher level. That shows n1 is equal n is equal to 1, 2, 3, 4, 5, 6. These are indicates as the first cell it is Lyman series, Balmer series, Pachon series, bracket series, and Fund series. Total have a 5 series, 5 lines it will shows. By using the hydrogen atom, it occurs in a different lines. It will occurs. This is the Bohr's model of an atom. Finally, it is observed by using the spectrometer, and that clearly we observe how much of lines it will occurs from the hydrogen atom. Thank you.